Hello, I'm Mr. Goan, and today we're going to be having a look at the National 5 Relationships Outcome 1.4, specifically covering the converse of Pythagoras, angles inside circles and polygons and all of your angles knowledge across straight lines, and the volume scale factor and its relationship there with linear scale factor. So let's get straight into it. The first question on this outcome is a converse of Pythagoras question. To pass the quality control inspections, this set square must have a perfect right angle. All necessary measurements are given in the diagram. Use the converse of Pythagoras theorem to determine whether this set square will pass the quality control inspection. Okay, so the converse of Pythagoras is used for testing if a triangle is right-angled. Now, we have to make an assumption straight away. We have to assume, firstly, that it is. And if it is a right angle triangle, then c squared would equal a squared plus b squared. Now, because we're making that assumption, what we need to do is to test it. Okay? So firstly, looking at our diagram, we need to decide which side would be c if it were a right angle triangle. Well, 11, 7.4, and 13.2 are our sizes. C is always the longest side, so C would always be that one. For posterity, that puts our right angle in that corner down here. So if that's true, then we can set up a calculation here. We can say then that 13.2 squared should be the same as 11 squared plus 7.4 squared. Now we can calculate that. We can say that 13.2 squared is 174.24. Now, we can do this in stages, or since we have our calculators, we can jump straight to 11 squared plus 7.4 squared, which is equal to 175.76. Now, we can see that these two numbers are not the same. Therefore, c squared does not equal a squared plus b squared. So we can say then that no, since c squared does not equal a squared plus b squared, by the converse of Pythagoras, the set square is not right-angled. And it's really important, there's some phrases in there that you do have to make sure you include. You have to say the since c squared does not equal a squared plus b squared, or if it did, you'd have to say that it does equal that. And you need to say this by the converse bit, by the converse of Pythagoras, since that's what we're using. And finally, whether it is or it's not right-angled. So the sentence gets you your hashtag mark, and the calculations here get your knowledge marks. Moving on to the next question. Question 14. The diagram below shows the design stages of a kite. Kite STUV and a circle with center T are detailed in the diagram. SV is tangent to the circle at S, and UV is tangent to the circle at U. Given that the angle STU is 146 degrees, calculate the angle of SVU. Now, since these are SV and UV are tangent to the circle, we know that they exist at right angles there to the radius. And we know also that these are radius lines since they come from the point to the center of the circle. Now, kites like this are symmetrical, so there are two methods we could use for this. We could split it into a right angled triangle by halving the angle at the top, then using our knowledge that triangles add up to 180 degrees. So we could do it like this, where we have our right angle in here. We know that half of 146 is 73 degrees. We have an angle in here then that is x, and we can say that x is equal to 180 minus 90 minus 73, x equals 17 degrees. And since that was half of our kite, down a wee line of symmetry there, we can double that. We can say that SVU is equal to 2x. So SVU must be equal to 34 degrees. Now, if we want to use the triangle method, that's how we could do it. Split it into two right angle triangles. You just simply have to remember to double the angle that you find at the end, since there are two of them. The other method is our knowledge that all quadrilaterals add up to 360 degrees. So what we get then is that SVU is equal to 360 minus 90 for our two right angles, minus 146. So SVU is still equal to 34 degrees. And we can check that with our calculators, and it's really up to you which method you want to use. Almost everyone can remember that triangles add up to 180 degrees. Quadrilaterals adding up to 360 does slip the mind easier. So, moving on to the final question for this outcome, question 15. An Olympic torch used in 2012 is 900 millimeters long. The volume of fuel stored inside the tank of the Olympic torch is 25,000 centimeters cubed. A similar miniature version is 180 millimeters long. Calculate how much fuel is needed for the miniature Olympic torch. What we need to do there is use our scale factor. We have a large torch and a small torch that is to scale. So we have an old model and a new model, and our scale factor is equal to new divided by old. So we pick a measurement that we know on both. We know how long each is. So what we get there is 180 divided by 900. And 180 divided by 900 on our calculators should come out as 0.2 or 1/5. And you can get that through cancelling as well. 18 over 90 is 2 over 10, which is 1 over 5, which is 0.2. Now that is our linear scale factor. At National 4, that would have been enough. However, at National 5, we need to know the relationship between linear scale factor and volume scale factor. And the volume scale factor is the linear scale factor cubed. That means that our volume scale factor, our VSF, is equal to 0.2 cubed. Now I don't need to work out what that is because I can just use my calculator for it later. But now we need to look back at our numbers. We want to find out how much fuel is needed for the miniature torch. So the miniature torch, so the miniature fuel, is going to be the large full-size torch, the fuel it requires, the 25,000, multiplied by our volume scale factor, 0.2 cubed. And as I said, we can throw that straight into our calculators. 25,000 multiplied by 0.2, and you want to use the y to the power x button, or it may look like an up arrow on your calculator, to add in that that is cubed, not squared, giving us a final answer of 200 centimeters cubed. The key to this question is working out the relationship there between our linear scale factor and our volume scale factor. Between them is area scale factor, remember, which is the linear scale factor squared. Now I hope this has been helpful, and good luck with your relationships module.